Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and during this segment, we're going to talk about quality. I'll show you this PowerPoint on what quality is, because it's very important that we understand quality. Now, quality is a subjective term. It can mean anything to anybody. But I'm going to break down quality to where we use it in the industrial engineering field. Now, what industrial engineers do, they look at a big system and they try to find the most effective way, whether it's reducing wait times or costs and waste in order to have an efficient system. Again, when we deal with industrial engineering, it's about energy, it's about people. That branch of engineering has a business appeal along with the technical appeal to it. But one aspect that is featured in industrial engineering is quality. So tonight, I'm going to get into the introduction to quality. Now, again, what you see is real information. In fact, this is one of my courses that I'm taking for the spring semester. So when we deal with quality, we're talking about managing quality improvements. So this first slide talks about meaning of quality and quality improvement. So the first question is, what is quality? Describe a situation where you experienced poor quality. Well, the meaning of quality and quality improvement. And here's what you have to understand. Quality takes on a different meaning to each of us depending on whether it is a product or service. Product quality tends to be more focused on the tangible or physical characteristics and capabilities of the item. Service quality tends to focus on intangible characteristics such as time, customer service, interaction with service provider. Now, when we deal with quality improvement, and we're going to be stuck right now on customers, because while customers view products and services differently in terms of what quality is, there are very few things we consume that do not have some aspect of both quality and service characteristics. The blending of goods and services known as servitization, and it has changed our perspective of quality and quality management. Now, I don't know if you can see it or not. Let me open it up a little bit, this PowerPoint. So when we break everything down, you have your goods, you have your services. Under services, you have your surgery, teaching, songwriting, software development, computer repair, restaurant meal, home modeling, retail sales, automobile assembly, steel making. Now, again, when we deal with quality, and you all are in the industrial engineering field in supply chain management, and I'm going to get into that as well, you're going to understand the dimensions of quality, 5S, Six Sigma. Now, the dimensions of product quality, when it comes to customers, they tend to view product quality in terms of 8 characteristics, starting off with performance, main characteristics of the product, Then you have your aesthetics, which deal with the appearance, feel, smell, and taste. There are special features, which have extra characteristics, like could be color, could be design. And you have conformance, how well the product conforms to design specifications. A good example of that is a construction project. Reliability, consistency of performance. Durability, when we deal with the useful life of the product. Perceived quality, which is the indirect evaluation of quality. And serviceability, handling of complaints or repairs. Also, customers tend to evaluate service quality in terms of convenience, the availability and accessibility of the service. Reliability, ability to perform a service, dependability, consistency, and accurately. Again, reliability, ability to perform a service, dependability, consistently, or we say consistency and accuracy. Responsiveness, willing to help customers in unusual situations and to deal with problems. We deal with time, which that is the speed with which the service is delivered. Assurance, having the knowledge exhibited by personnel and their ability to convey trust and confidence. Courtesy, the way customers are treated by employees. Tangibles, the physical appearance of qualities. Correction, the physical appearance of facilities. Again, when we deal with tangibles, we deal with something physical. So we're going to look at the appearance of facilities, equipment, personnel, and communication materials. Consistency, the ability to provide the same level of good quality repeatedly, or we can say consistently. Now, again, the book has the authors, they have combined the dimensions of quality into these 11 different functions: performance, features, reliability, durability, conformance, aesthetics, serviceability, perceived quality, professionalism, and attentiveness. Now, when we talk about performance, it's what the product or service does. The features, what characteristics does the product or service have above and beyond its performance? Reliability, time between failures or need for maintenance. Durability, how long will it last? How does it hold up under normal and extreme conditions? Conformance, was the product or service made to specifications? Again, when we deal with aesthetics, how well does the product or service look or feel? Serviceability, how easy was it to repair, maintain, or support? Perceived quality, we deal with the reputation or image of the product or service. Professionalism, do the employees or the salespeople or the service provider, do they have the knowledge and the skill to talk about their product? In other words, knowledge and skill of service provider as it relates to competency. And attentiveness, customers' desire to feel their wants and needs are being addressed. Providing customers with quality. Now, in order to provide high quality goods and services, organizations must understand what dimensions of quality are most important to users. Again, here's an example. When you buy a cell phone, whether or not it can be serviced is probably not important, since you will just get a replacement if something goes wrong. Develop products and services that meet customer requirements. And we're going to talk about an example of the greatest smartphone in the world is of little use if the network cannot support it. Then we get into develop business processes that meet specifications and user requirements. Example, it is not enough to have a great product, you have to support it. And then we verify business processes and meeting specifications. So if you don't measure how you are doing, you won't know whether you are succeeding or, of course, failing. Now, again, we get into the traditional definition of quality, and that is based on the viewpoint that products and services must meet the requirements of those who use them. This is known as fitness for use. Fitness for use can be broken down into two categories: quality of design, quality of conformance. Now, when we talk about quality of design, it describes the intentional levels of quality built into the product or service. And when we deal with quality of conformance, it describes how well the product or service conforms to specifications. Now, if we look in terms of variability, because we're on a modern definition of quality now, then our goal is to reduce variability to increase quality. So a decrease in wait time variation for customer service will result in higher perceptions of service quality. A decrease in variation of color for automotive components will result in higher perceptions of product quality. Again, variation is basically what this course is about. Time and time again, our focus will be on examining variation in a product or process in order to assess quality. So in order to produce quality products and services, you still need to know what the customer wants and expects. So once you've identified those characteristics, then you go about managing quality. And what you want with that quality, you want to talk about, or you want to investigate how to reduce the amount of variation that's in a product or service. Again, we start to get into quality improvement. Now, when we talk about quality improvement, I'm just going to say this. If quality is affected by variability, then in order to improve quality, we must control and reduce variability. The quality improvement is designed as the reduction, is defined. Again, quality improvement is defined as the reduction of variability in processes and products. Too much variability results in wasted labor, material, time, and customer satisfaction. So you can take the concept of quality improvement to a step further and focus on waste reduction, which is the goal of lean manufacturing. And I'm gonna get into that as well. Now, in every field, you have to understand terminology. So quality terminology, I'm going to get into this slide, and I'm going to talk about the expectations, because we as customers have expectations to what we want and know about quality. So we expect a good price, a good product, and a good service. So the expectations the customer have with respect to quality are known as quality characteristics. So in the product, quality, and design engineering worlds, they are known as critical to quality. And you're going to see this acronym called CTQ. CTQ is critical to quality characteristics. So CTQs fall into two categories: physical, sensory, time, orientation. So what would be some CTQs for a product? How about a service? Well, when we deal with QE, which is quality engineering, it's the set of operational, managerial, and technical activities that a company uses to measure and monitor quality. Now, a brief history of quality control. Now, if you have the textbook is going to tell you that it's going to give you a summary of major events in the areas of manufacturing and quality. And see, industrial engineering, in my humble opinion, was a break off of mechanical engineering. Frank and Lillian Gilbreth were some of the architects of industrial engineering. Henry Ford was an industrial engineer as well. So when we deal with quality control, it got its start as a result of World War II, because after the war, quality gurus such as Geron and Deming preached the virtues of quality management systems to American companies. And Japan, they embraced quality management techniques and principles. So in the 70s and 80s, American companies began to recognize the competitive advantage that Japanese communities had. So this is where you get in the 90s, ISO 9000, QS 9000 were adopted. Motorola, GE adopt Six Sigma approach to quality. So today we see quality management systems embedded into the operations of manufacturers and services with an emphasis on continuous improvement and reducing variability. Again, where's all this leading to? We're getting into something called statistical methods for quality control. So what I'm going to teach you is how statistical techniques are used in quality improvement. Now, why do we use statistics? Because for most of us, statistics, they're not very enjoyable and they're not very understandable. But different circumstances call for different tools and techniques. So it is not always intuitive, because in statistics, 2 + 2 probability equals 4, but we cannot be 100% sure. Now, statistics is a study of variation. So we will talk about means and medians and modes, but what makes stats useful in its ability to describe variation. And as we discussed earlier, the modern definition of quality focused on the reduction in variability. So a branch of mathematics that focuses on quantifying variation is an excellent tool for investigating and improving quality. And that is, of course, statistics. Now, again, the textbook focuses on 3 areas related to quality management. That's SPC, and you'll hear that in the manufacturing sector. The statistical process control. Then we have design of experiments and acceptance testing. In fact, in construction, there's a lot of acceptance testing. Now, regardless of the area each of these tools utilize, statistical tools that evaluate variation as a means of identifying and improving quality issues. So the generic model looks like this, okay? You have your inputs, you have your controllable variation, all in a flow chart. You have your feedback adjustment, you have your product, your measure and your evaluation. And then you also have your uncontrollable variation. Again, statistical process control will be the main focus for quality, because it's very important. Because again, when you utilize statistics, it's going to allow for some variation. Now, SPC, which stands for Statistical Process Control, utilizes statistical tools to monitor variation in a product or process. Also, control charts are used to identify and quantify variation in data. And again, as we get further into this course, we will look at a number of statistical tools to help us make decisions about the type and frequency of variation in our data, but control charts will be our main focus. Now, again, control charting is a graphical technique that allows us to monitor magnitude and variation in a quality characteristics, in a quality characteristic. And at the bottom of my slide, you will see an example of a control chart. Also, design experience, correction, design experiments, known as DOE. Design experiments is a technique that allows us to evaluate how variation in different factors affects quality characteristics of product or process. So when we break it all down, a factor, deal with factors. A factor is something that is believed to have an impact on a critical to quality, here comes CTQ again, characteristic. Again, critical to quality characteristics are those aspects of the product or process that are important to monitor and control in order to deliver quality goods and services. Now, DOE, which stands for Designed Experiments, identifies key factors and varies them in a systematic way to observe the outcome on the CTQ. DOE is a powerful tool because it allows us to use statistical tools to predict what will happen if we change our design or process without making a widespread change. Also, I love acceptance testing. Now, again, no matter what field you're in, when you're doing inspection, you're going to have tests. So traditional inspection techniques would rely on 100% inspection to evaluate material. Now, the main problem with 100% inspection is that it is expensive and it does not catch 100% of the failures. So acceptance sampling involves inspecting and testing a subset or a lot of material or product and making a determination about the quality of that lot based on a subset of that lot. Now, let me give you a good example of that. I work in a construction field, and we take asphalt and we break it down into different lots, and we have acceptance sampling. Now, this is probably what most people would associate with incoming inspection, while closely relating it differs in that we rely on samples and the variation in those samples to draw conclusions about the quality of the lot. Quality cost, as our experiment shows poor quality costs. And when poor quality happens, it costs companies and organizations money. So contrary to a popular quality slogan from the 80s, quality is not free. So improvement in quality by monitoring and investing in process and products will reduce your overall cost of quality. See, cost of quality consists of a number of sources. These have been simplified into 4 categories. Now, the cost of quality. We have internal failure. These costs are incurred prior to delivery. So when we have internal failures, we're going to have scraps, reworks, we're going to have to retest. There's going to be downtime and yield loss. That's why you want to do it right the first time. And we have external failure. These are costs that are incurred as a result of defective material or service reaching the customer. So some examples of external failures: discounts and adjustments, warranty charges, liability costs, and of course, indirect costs. Not fixed costs. We have fixed costs and we have variable costs as well, but they're not part of this equation. Then appraisal, which cost the company incurs to evaluate its quality levels. So examples of appraisal cost are inspection testing. And we have prevention. Basically cost a company, it's the cost that a company incurs to prevent defects from occurring. So examples are quality engineering, new product development, product process change, training quality, and then we have I can say training quality management system known as TQM. When I was in the military, that term came up, TQM, and of course, DMAIC came up, design and analyze. We're going to get more into that as we are in our industrial engineering phase. Of course, here's a chart, quality improvement, total cost, X and Y axis. Here's how your total cost are formed. And here are all the categories: appraisal, prevention, internal failure, and external failure. Again, quality cost. One question you have to ask is, how much do companies spend on quality? Well, quality cost is significant in all companies because it varies depending on the industry and the level of quality management and control in the company. Estimates range from 5% to 40% of sales. So regardless of how much companies spend, the bottom line is improving quality, because good quality and bad quality has an effect on an organization's bottom line. Then you have legal cost of quality. You see, quality is not just an expectation of customers, but a legal expectation. Why? Because you're not allowed to sell a product that does not do what it is supposed to do. Why? Because there is a legal responsibility and expectation that your product performs in a manner consistent with how it is promoted and what its intended use is. There is also a legal responsibility not to sell dangerous or defective products. Defective products that cause injury can result in recalls, product liability suits, or we call them class action suits, and of course, customer dissatisfaction. So, how do we implement quality improvement? Well, most successful companies will utilize a quality management system in order to monitor and improve quality. This is important. A lot of your successful business already implement a quality management system so they can monitor and improve quality. Again, quality management systems consist of 3 items: quality planning, quality assurance, quality control, and improvement. Now, quality planning is part of the strategic planning process for the company. Quality assurance is the set of activities that ensures quality levels are maintained and customer issues are resolved. Quality control is the set of activities used to ensure products meet requirements. In construction, we say standards and specifications. Now, as I conclude, I want you to understand that quality is important in all aspects of business and your life. So now we have a definition of quality and a basic understanding of quality, dimensions, and costs. In the next chapter, I'm going to focus on managing quality in organizations. So again, if you like what I just presented, definitely look at this video. This is good information, especially if you all are interested in the field of industrial engineering, because quality does cost money, but without quality and testing, you don't know what type of product you're getting. So if you're running a business, be sure to install a quality management system, because your system could be the treasure to more money in your pocket. And it's also going to give you an idea of what you need to improve. And that concludes this topic on quality control. If you like what I just presented, please comment, share, and subscribe. And if you're looking for hard-hitting political content, news, other information, check out the 401 Talk Zone radio show. On that channel, I'll be doing some live streams every Friday, but I'm also going to promote this channel because I like this channel as well. So please like, share, and subscribe to this channel, the STEM channel. On this channel, you get a daily dose of science, technology, engineering, and of course, math. Now, if you can't find me on YouTube, you can check the 401 Talk Zone radio show out on Twitter, MeWe, and Parler. Right now, it's on Twitter. Now, when it comes to the Mind of STEM channel, check this channel out on Twitter and, of course, LinkedIn. And once again, I thank you all for viewing and listening to the Mind of STEM channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.